Good morning, my dear students. This is our 8th lecture of Laplace Transformation, and today we will see what I can call is as application of Laplace Transformation, where we apply it. We are going to use it to evaluate certain tedious integration. So for that, we will need what we have learned in Laplace. So let's have a recap in 1 minute. We had seen first shift theorem. What I explained you, when we use first shift theorem, when you want to find Laplace of e raised to at into some function, and how we find Laplace of ft and replace s by s minus a. That was first shift theorem. Then we have seen change of scale property. What it says, Laplace of f of at is 1 by a into f bar at s upon a. Then we had seen Laplace of multiplication by t, means when you want to find Laplace of t into some function, how do we find? Just find Laplace of this ft, which is f bar s, and into t means take its derivative with minus sign. After that, we had seen Laplace, where we use division by t theorem, that is whenever it is Laplace of some function upon t, again find Laplace of ft, it's a bar s integrated from s to infinity. Now using all this, today we are going to see in this video where we are going to use it. We are going to use it to evaluate some particular type of integrations. So let me start with one problem. Our problem is say, remember, understand this part, we are not finding Laplace. The question is not find Laplace. Question is evaluate the integration, and we are taking help of Laplace to evaluate the integration. As an example, let's have one integration 0 to infinity e raised to minus st t sin t dt. Now you can see here this integration is a bit tedious to evaluate. Sometimes I will say it's impossible for us. We have seen u into v, integration of u into v already done in your 12th standard. Integration by parts, you can see here there are 3 terms. If you want to use any method, maybe substitution, maybe by parts or any other thing, this integration you can find is bit tedious, and so we are going to take help of Laplace to evaluate this integration. Let's see how it works. So initially I will call this integration as I, and my first step will be just write e separately and rest all terms you write together. Maybe there are 100 terms, but write e separately and rest all you write together. Then you can understand this is nothing but Laplace of t sin t at s equal to 1. This is the most important step. Rest everything you have already done. So I'll just take more time for this step. If you understood, well and good. Otherwise I will explain you this step. Just go back for definition of Laplace of ft. Definition of Laplace of ft was integration 0 to infinity e raised to minus st ft dt. So I will just write one example here. See, if I have integration 0 to infinity e raised to minus st sin t dt, then clearly you all can understand this is Laplace of sin t, and because it is Laplace of sin t, you know it is 1 upon s square plus 1. Why I have taken this example? To understand this one step, which is actually very important. Listen carefully. We got this integration is 1 upon s square plus 1. Understand one point. instead of s, if I take here u, it's a parameter. Understand this point very well. Instead of s, if I take here u, what we will get? 1 upon u square plus 1. Instead of s, if I take here x, I will get 1 upon x square plus 1. So instead of s, if I take 4, means say as an example, if I write here e raised to minus 4t sin t dt, then clearly what we are going to get? In place of s, it will be 4. I hope you understand this. In place of s, I am taking here 4. So here also in place of s, I will get 4. So this integration will be 1 upon 4 square plus 1. Means I will say this integration is nothing but this 1 upon s square plus 1. Here we are going to put s equal to 4. That means what we have done in Laplace of sin t, whatever is Laplace of sin t, there we are going to put s equal to 1. Understand this step very well. I am repeating e raised to minus 4t sin t dt. If you compare with e raised to minus st sin t dt, this is Laplace of sin t. So this will be Laplace of sin t at s equal to 4. And if you understood this, I will go back to our problem and you can understand now what we had done. This integration 0 to infinity, this is the integration which we wanted to find out. 0 to infinity e raised to minus t sin t. So this will be Laplace of t sin t at s equal to 1. And so our problem is nothing but, now this was just a part for your understanding. Let me continue with the problem. This is Laplace of t sin t at s equal to 1. So our problem actually just starts with now how to find Laplace of t sin t. And I hope all of you know how to find Laplace of t sin t. Here this is multiplication by t rule. So we have to find Laplace of sin t and it is multiplied by t. So we have to take its derivative with minus sign. And you know what is the derivative? This will be 2s upon s square plus 1 whole square. And finally, therefore, I will just have put s equal to 1. Why s equal to 1? We are at this step that our integration I is nothing but Laplace of this at s equal to 1. And so after finding Laplace of t sin t, now we are just putting s equal to 1. So we are going to get I as 2 upon, this is 1 plus 1, 2, its square is 4. So this was the basic concept to evaluate the integration which is in terms of e raised to minus st ft and the limits are 0 to infinity. So just have a look. To evaluate integrations of this type, we take help of Laplace. Let's have one more problem of the same kind. Now I will have a problem again. It's evaluate. I will start with my I is 0 to infinity cos 60 minus cos 4t upon t dt. Now you can see here the limits are 0 to infinity, but there is no term of e. So we will introduce it. We can write this as e raised to 0t cos 60 minus cos 4t upon t. And now I think you can understand very well. This is nothing but Laplace of cos 60 minus cos 4t upon t at s equal to 0. And this is a problem we have already solved in our previous video. Cos 80 minus cos bt upon t. It's upon t. upon t means what we do? It is, you have to integrate Laplace of cos 60 minus cos 4t, which is s upon s square plus 36 minus cos 4t is s upon s square plus 16. We have to integrate this from s to infinity with respect to s, and the same problem we already solved in our previous lecture. Just continue it, and lastly what you have to do is, see, this I is nothing but Laplace of this at s equal to 0. So after solving this, you have to just put at s equal to 0. So this part I am leaving as an exercise. You can do it very well. So I hope the concept is clear. I am just telling you once again, all these videos are just to clear the concept. You need to solve more and more problems. And if you have any query, please mail me. I will try to answer it. So this was evaluation of integration, and that's the end of the Laplace transformation. Of course, end in the sense Laplace transformation on anything in mathematics is never going to end. I'm just saying this is the last video of Laplace transformation, and in the next video we are going to start with inverse Laplace. So till then, goodbye and have a nice day. Thank you very much.